Hi and welcome to PM Coding Tutorials. Today I will show you how to code this JavaScript project. It is a photo editing app that allows you to upload an image from your computer, apply different filters to it, and then download the edited design. It only requires HTML, CSS and JavaScript, no need for any third-party libraries, and the complete JavaScript code is less than 100 lines long. Hopefully, this JavaScript project will inspire you to build your own photo editing site, which you could maybe even add to your coding portfolio. So, let's get started. In VS Code, I have my project open. It consists of an HTML, JavaScript, and CSS file. The index.html already has some basic code in it, where I added the head and body tags and linked the JavaScript and CSS files. Both the JavaScript and CSS are empty for now. I'll start off with adding the necessary HTML markup. First, I am adding the main tags. Inside, I am nesting an H1 with the text "Apply filters to your images." Below the H1, I am adding a form. We are not submitting its content to any backend, so we don't need to specify any action. Then, inside the form tags, I am adding a label with the for attribute image and the class SR_only. The SR_only will ensure that the label is not visible on the page but still available to screen readers. Below the label, I am adding an input of type file which allows the upload of files. Both the name and ID I am changing to image. The value of the ID attribute and the for attribute of the label should be the same so that the two get tied together. This is important for accessibility. I want to limit the file types that users can upload, so I am adding an accept attribute and am setting its value to a comma-separated list of allowed formats such as image/png and image/jpg. Continuing on, I am adding a div with the class container below the form. The container class will be responsible for positioning its child elements in a grid. If you would prefer adding your own design, you can omit the classes and create your own later on. They don't relate to the JavaScript functionality, as you'll see in a bit. Inside, I am adding a canvas element which will display the uploaded photo. Below, I am adding a div with the class buttons. This div will hold the filter, the reset, and the download buttons. I am then nesting another div with the class filters, which will hold the filter buttons only. I am adding 3 buttons here, the first for the Grayscale effect with the ID and text of Grayscale. Next, I am doing the same for the Monotone and Duotone effect, but adjusting the ID and text as necessary. Finally, I am adding a final div with the class actions. Inside, I am adding a button with the ID reset and the link with the ID download. Please remove the href attribute from the anchor tag. We will generate this dynamically with JavaScript. Also, please add the download attribute onto the link so it can be used to download data. Inside the button, I am nesting an SVG, which displays as a download icon. I got this icon from Hero Icons, which I have linked in the description if you would like to use the same one. Below the SVG, I am adding a span with the text download. That's all the markup we need for this project. I am starting my live server to see what it looks like at the moment. If I upload an image from my laptop, you can see the name, but it doesn't display the photo yet. We'll add this functionality with JavaScript next. One quick note before we move on to the JavaScript portion. In the index.html file, please add the defer attribute to the script tag. This will ensure that the JavaScript code only gets executed after the DOM is finished loading, which is important as our code can only access the HTML elements if they are already present. The first thing we need to do in the JavaScript file is to access the DOM elements we want to interact with. These include the canvas, the buttons, and the input element. I am selecting the canvas element with document.querySelector, which will return the first canvas element on the page. We only have one, so it's ideal in this case. To be able to interact with and draw to the canvas, we need to get its context. This we can do with canvas.getContext and then passing the string 2D as an argument. In the description, I have linked further resources on this topic if you want to look further into it. Next, I am selecting the filter, download and reset buttons plus the input field by their IDs. Finally, I am adding variables with the name image width, image height, and original data. These will hold information required by several of our functions, so I want to add it to the global scope. The information they hold will change, so I am using the let variable instead of const, so I can reassign their values. To display the uploaded image on the page, we need to keep watching for file uploads, so whenever a user uploads a photo, we can then read the content of the file, create an image with the data we read from it, and finally draw it to the canvas's context. For this, we need 3 event listeners. Let's begin by creating the image that will get drawn on the canvas first. I am defining a variable called const image and I'm setting it equal to new image. This will create an image element for us and is the same as if you were to write document.createElement and then pass the string img as an argument. Next, I am adding an event listener to the image. The event we are listening for is called load and will fire when the image element has been fully loaded. In the event listener's callback, I am setting the global variable image width and image height equal to the image's width and height. Then I am also setting the canvas's width and height equal to these values. Finally, I am drawing the image to the context of the canvas with the function drawImage. We need to pass 3 arguments to draw image. The first one is the image itself, the second and the third are the coordinates from where the image should be drawn. In this case, I wanted to start on the top left corner of the canvas, so I'm setting the coordinates to 0 and 0. To be able to read the file contents of the uploaded image, I need to use JavaScript's file reader. I am defining a variable called reader and I'm using the file reader constructor to create a new instance. Here again, I need to attach an event listener. In this case, we again listen to the load event, which fires when the file reader successfully completes reading the file. There are other events you can also listen to, for example error, which fires when the file cannot be read. Again, I linked further resources in the description if you want to dive deeper into the topic. In the callback of the event listener, I am setting the source of our image, which we previously created, to the result property of the reader object. I am also assigning reader.result to the original data variable we defined in the global scope. I want to always keep an unedited version of the uploaded image in this variable, so when the user clicks the reset button, we can set the content of the canvas equal to the data stored in original data. Finally, I am adding an event listener to our input. The event we are going to listen for is change and will fire anytime the user uploads a new image. The callback will make use of the reader.readAsDataURL function, which receives the uploaded file as its argument. The readAsDataURL will then start reading the contents of the image. So basically, whenever a user uploads an image, first the input event listener will get triggered, which starts reading the file's content. Once this is complete, the next event listener attached to the reader variable is fired. This sets the image's source variable, and finally, once that has finished executing, our image event listener gets called and we end up with the image displayed on screen. One event listener is invoking the other. With this in place, we have all the code required to display the image on the canvas. Let's see if it works. I am uploading the image and the dog photo is painted on the screen. Next, we'll add the filters. I will start by creating the functionality for the Grayscale image. For this, I am defining a function called applyGrayscale. Within the function, I am using context.getImageData, which returns the pixel data for the context of the canvas. This will make more sense once you see its value, so I am going to console log it. To see the result, let's quickly attach a click event listener to the Grayscale button, which will call the applyGrayscale function whenever we click on it. In the browser, I am uploading a photo and opening DevTools. When I click on the Grayscale button, I can see an image data object printed to the console. Let's see what's inside. Expanding it, you can see properties such as color space, height, and width. What we really care about is the data property. It holds the RGBA information of each pixel. Expanding it, you can see it is huge and comprises a long list of integers. These numbers represent the RGBA values of each pixel. RGBA stands for red, green, blue, and alpha. By mixing different amounts of red, green, and blue, you can create different colors, as you can see on W Free School's page on RGB colors, which I linked in the description. Alpha, on the other hand, is responsible for transparency. If the value is 255, it is fully visible. At 0, it is transparent. I made a diagram which will hopefully help illustrate how the data is structured. So the first 4 values represent the configuration of the first pixel of the image. The first number is the red value, the second the green, the third the blue, and the fourth is the alpha. By mixing the red, green, and blue values, we get the color of the pixel, and the fourth tells us the opacity. The next 4 numbers inform us of the same information but for the second pixel, and so on. We can loop through the array of these numbers and use these RGBA values to manipulate the look of the image. Back in VS Code, I am removing the console log and instead am saving the array of numbers into the image data variable. Then I am adding a for loop. The iterator I will start at 0, so the very first array element. The loop should keep on going until the end of the array. Whenever one of the iterations finishes, I want to increment I by 4. The reason for this is that each pixel is represented by 4 values within the array, as you could see on the diagram. Within the loop, I am saving each color value into its own variable. Red will be the first value within the iteration. Green we can get by adding 1 to I, blue by adding 2. We can also access alpha by adding 3, but we don't need alpha for this project, so I am removing that. Gray shades are made up of equal values for each color, so to turn an image into a grayscale image, all we need to do is add the red, green, and blue values together and divide it by 3 to get their average. Once we have the gray value for the pixel we are iterating over, we can edit the value within the array by updating the red, green, and blue values to the gray value we calculated. We can use the same indexes for this as we used to initially get the color value. Finally, once all is done, we need to draw the edited image onto the canvas. We can do this with context.putImageData and passing the same argument we did with drawImage in the image event listener at the beginning. Next, let's add the monotone filter. I am defining a function called applyMonotone. To ensure I don't forget to assign it to the monotone button, I am going to attach it through a click event listener right away. As the functionality of applyMonotone is pretty similar to applyGrayscale, I can copy most of the code over and make some minor changes. We will refactor this later on, so there is no code repetition. To make one color prominent in the image, we need to increase its value. In this case, let's make blue dominant. For this, I can simply assign gray value plus 80 to the blue value of the pixel. Now, if I upload an image and press the blue monotone button, the photo gets a blue tint. Because we increased the value of blue, the overall brightness of the image also increased. The higher the color values, the brighter the image will get. For this photo, it looks okay, but if the photo was much brighter, it might cause issues. So to counteract the brightness change, I am going to decrease the values of red and green by half of the value of the blue colors increased. By doing this, the image retains its original brightness. We can change the tint to other options as well. To create a magenta hue, increase the red and blue values by 40 and decrease green by 80. To get a cyan hue, reduce red and increase blue and green. Feel free to experiment around and come up with your own hues. Finally, let's add the Duotone filter. I am defining the apply Duotone function and assigning it to the Duotone button with another event listener. To create the Duotone effect, I came up with the algorithm myself after experimenting around for 2 hours or so. I will try to explain it as much as possible, though if you don't understand, that's okay as you can still use it. So whenever we calculate the gray value by getting the average of red, green, and blue, we get a value between 0 and 255. 0 is the color black, 255 is white, and anything in between is a different shade of gray. The higher the value, the lighter the gray. The middle point between 0 and 255 is 128. To apply a duotone, I want to check how far away the gray value is from this middle point. For this, I can use percentage. As 128 is the reference point from which I want to calculate the difference, 128 becomes the 100% mark. Then, with the formula 128 divided by 100 and multiplied by the gray value, I can figure out how much percent the gray value is of 128. Back in VS Code, I am going to calculate the percentage with the help of this formula. Sometimes though, percentage calculations return decimal numbers. I want them to be integers, so I am using math.random to round the number up or down. The result I am then assigning to the diff variable. For the red value, I am setting the value of the gray value variable with the value of diff added. Green will be set to the regular gray value. And blue will become 255 minus diff. If I now save, you can see the duotone filter being applied to the dog photo. You can also make the filter have more magenta hues by setting blue to simply be 255. Feel free to play around with it and change the numbers to see what sort of filters you can come up with. Not all color combinations work for each image flow. You could also try creating your own algorithms. Perhaps you can come up with a better approach. As you might have noticed, all the filter functions have a lot of code in common. Let's refactor to remove code duplication. I'm declaring a function called applyFilter. This will receive one argument, and that is the filter type. From the applyGrayscale function, I am copying over all the code. Everything will remain the same apart from where we assign the gray value. Next, I am defining an object called filters. This object will hold several methods, each handling the logic responsible for calculating the values for the three colors. The first method will also be called applyGrayscale. It will take one argument, and that is the gray value. It then will return an array of values, one for the red, one for the green, and one for the blue color. For the grayscale filter, these will all be the same. Next, I am adding the applyMonotone method, which takes the same argument. It also returns an array of three values, but here we manipulate the return value by subtracting 40 from red and green and adding 80 to blue. Finally, let's add the method for applyDuotone. Here we additionally also need to calculate the diff value, which I am copying over from the original applyDuotone function. Make sure you rename gray value to gray as we named the method parameter so, or else you'll get a reference error. And then we adjust the values returned in the array again. With this in place, let's go back to the applyFilter function. I am declaring a data variable which will hold the array our filters object's method returns. I want to call the functions dynamically based on our filter type value we pass to the applyFilter function. For this, I can use the bracket notation and pass filter type in. Since it is a function, I need to call it, so I am appending parentheses and am passing our gray value to it. Next, we need to update the values for the pixels within the image array. For the red value, I am using the first value at index 0 of data, for green the second, and so on. Now we can delete all three functions as they are no longer needed. We also have to update the button event listener with the new function name. As we have to pass arguments, I am defining anonymous callbacks which call the applyFilter method and pass the filter name. Let's test it. All three filters work. When I click on the reset button, nothing happens though. Let's implement that functionality next. I am adding a function called resetFilters, and I am assigning it to the reset button through an event listener. Before resetting the image, I want to check if there is one, whether we have the context of the canvas, and whether we have the original data saved. If not, resetting won't work because no filter has been applied or image uploaded. And so I want to inform the user of this. For this, I can return an alert prompt with the error message. You can of course change this so the error message gets displayed on the page instead of an alert box showing up. For simplicity and to make this tutorial shorter, I went with this easy implementation. If we do have an image, context, and original data in place, we assign original data to the image.src property. Then we draw the image to the context of the canvas. Let's try it. All seems to work as expected. Let's also add some error handling to the apply filters function. If there is no image uploaded and we try to apply a filter, we get an error. So to avoid this, let's add an if statement which checks whether image width or image height are missing. If one of them is, we return an alert asking the user to upload an image. If we test the page, you can see that the alert messages appear when the user tries to use a filter or reset the image. The last thing we add is the download functionality. At the end of the apply filters function, I am setting the href attribute of the download button equal to canvas to data URL. This method returns a data URL containing a representation of the image we can then download as we added the download attribute to the button. If we upload an image and apply a filter, you can see that the download link becomes blue and gets an underline. That's because the href attribute was set. When I click on it, the download starts and I get a copy of the edited image. With this, the JavaScript for this project is done, and it took us only 83 lines of code. The style I will not go through, instead I will just copy paste it in as it doesn't relate to the functionality. I linked my GitHub repo below, so you are welcome to reference it in case you would like the same or similar design. I do, however, encourage you to make this project your own, to play around with the filters and style so you learn more. Looking at the final project, the buttons at the bottom are positioned incorrectly. Seems I have made a small mistake with the HTML. And yes, the div with the actions class would need to be nested inside the div with the buttons class. With this corrected, the project looks and works as it should. I hope you enjoyed this video. If you did, please subscribe. If you would like to know how I created the gradient hover effect for the Duotone button, click the card that should appear in the top right. For any questions, please leave a comment below. You can also reach out to me on Twitter under @pmcoding. Thanks so much for watching and see you next time.